Alright, here is the first question of homework 9. Suppose Wt is a stochastic process with E omega t is equal to 0 and R omega t1, t2 is equal to alpha minimum t1, t2. Define yt is equal to Wt minus 1 for t is bigger than or equal to 1. And equal to 0 for t is less than 1. Find E, yt and R, y, t1, t2. Is yt widespread solution? We can, from the condition, we can say that E omega t is equal to 0 and R omega t1, t2 is equal to R alpha minimum t1, t2. So we can get a conclusion that omega t is a Poisson process. So we can write omega t is equal to this equation, and then we can easily find we can easily write down yt is equal to E omega t minus omega t minus 1 is equal to alpha, and R y t1 t2 is equal to this equation E y t1 y t2 and equal to this, and this has four conditions. First, when t1 is bigger than or equal to t2 minus 1, because here the time the time is from t minus 1 to t. So if t1 is bigger than t2 plus 1, ry t1 t2 is equal to E omega t1 minus omega t1 minus 1 E omega t2 minus omega t2 minus 1, which equals to alpha square. And the second condition is when t2 is bigger than or equal to t1 plus 1. Similarly, we can say that ry t1 t2 is equal to alpha square 2. And third condition, when t2 is less than t1 less than t2 plus 1, ry t1 t2 is equal to alpha square plus alpha. This can be solved by the it can be solved by the definition of the R y t1 t2. And when t1 is less than t2 less than t1 plus 1, similar to this, we can easily get the same result from these two. And in conclusion, we can write down ry t1 t2 is equal to alpha square when t1 minus t2 is larger than 1. This is the first and second conditions, and it's equal to alpha square plus alpha, which is when t1 t minus t2 absolute t1 minus t2 is less than 1, which is the third and the fourth condition. As t1 as ry t1 t2 is equal to r tau, and eyt is equal to alpha, which is a constant. So we can, from definition, we can say that yt is WSS.